Good morning, students. In today's class, we are going to discuss about the ensemble learning implementation part. So, in the previous classes, we discussed that how ensemble learning works and how ensemble learning is better than the existing normal classification models. We have discussed this. So, today we are trying to understand practically that if I'm using ensemble learning techniques like random forest and if I'm using any other model like SVM or decision tree, there is any difference between the performance of the model or not. So we'll try to understand with the programs. So what we are trying to do, we are trying to build a classifier which is used to compare the performance with an ensemble learning technique like random forest. And we'll use here we are using a simple data set which is related to the breast cancer, and we will train our model. We'll build one model which is SM classifier, and we'll build another model which is random forest classifier, and we'll compare the performance of these two models using various matrices like the season, recall, accuracy, and FN score. So as we know, our data set is a breast cancer data set, and it is a, we can say it's a well-known data set which we can use for training and evaluating the performance of the model if we want to perform the classification on breast cancer diagnostic. And most of the people are using this particular data set for different machine learning algorithms. So if I'm talking about the data set is consisting of total 569 instances are available, and there are around 30 features are available in the data set, and one is your target variable, which is representing that the person is having a cancer or not. So the features or the attributes which we are considering here, these are the 10 features which we are considering here. So radius, texture, parameter, area, where the cancer spread, what is the smoothness value, concavity, symmetry, all these features we have considered to detect a person is having cancer, breast cancer or not. And when we are talking about the outcome of our data set, the outcome will be a person is having cancer or not. So it is divided into two classes. One is called malignant classes and benign classes. Okay, so we are. I want to know that when I train my model on this particular data set, my model should classify or predict that person is having a breast cancer or not. It's a belong to benign class or malignant class. So this is all about the data set. Now, as we all know that whenever we are working with any machine learning or deep learning models, first of all we have to import the libraries. So first of all, we imported the libraries for the breast cancer data sets. We have imported the libraries from sklearn to import the data breast cancer data set. And as we know that for every data set, we have to do the train and test split. So I'm importing from sklearn, I'm importing train test split. Okay. As we are comparing the two model here, one is random forest classifier, which is based on the ensemble learning, and we are comparing the support vector machine. So we are importing support vector machine and random forest both, and I want to compare the results on the basis of accuracy, and I want to show the classification report which will tell me the precision, recall, and reference score. And the same way, I want to draw the confusion matrix for both. So we imported all these things. And as we know that we are using here matplotlib for plotting the graphs, so we imported that. So these are the libraries which we are going to use. So in every whatever model you are going to develop, you have to import some of the libraries as per the requirement of your code. Fine. Now, first thing is we are loading our data set. We are loading our cancer data set, and we are storing in a variable cancer. And now X is representing my input features and Y is representing my target outcome. Okay, this is my target value and this is my input feature. So we have loaded the data and we are given two variable X and Y. X is representing the input feature and Y is representing my target value. So fine, now we have to split the data into training and testing. So as we know that we have to split the data into training and testing. So here we are using 70% data for training and 30% data we are using for testing. So we have written here 0.3 and we have split the data into train and test, so that we are use X train, X test, and Y train and Y test. So X test is keeping my target value and Y test is keeping my again the target value for test data set. Okay. Now I'm initializing my classifier. So here we are using two classifier. One is random forest classifier and the SVM classifier. So we have initialized the random forest as well as SVM classifier using the random state value, which is 42. So I hope you know what is random state. If you don't know, please go through with the previous videos. I explained many times what is random state. Okay. Now after initializing the classifier, now I have to train my model on my training data set first. Okay, so we have to train the model. So first of all, I'm training my random classifier. I'm training and evaluating the random classifier. So I have used the random classifier here and I'm fitting my model on my training data set. So xtrain is showing my input feature and ytrain is showing the target variable. So I have fit my model, I have built my model. Now after building the model, I want to know how my model is performing on the test data. So I have to give the test data. So here I am not giving the label, just I am giving the input feature. So you can see here the difference. Here I give xtrain and ytrain both because I am training my model on data plus label. Now I want to see that how well my model have learned. So during the testing, we will not give the label, we will just give the data. So that's why we have given only X test. Okay. And finally, I'm trying to predict the accuracy of my model. So to predict the accuracy of my model, I'm using the actual value, actual label, and the predicted label, which is stored in the variable, this variable where we have done here. Clear? So we are comparing the results between the predicted value and the actual value. And now I want to print the random forest classifier performance. So for that, I'm using, I want to print the accuracy. So I'm printing the accuracy, which is stored in the variable rf underscore accuracy. So I printed the accuracy. Same time, I want to print the classification report between the actual value and the predicted value. So I'm just calling a function which is called classification report, and I'm giving two parameters, which is my actual value and the predicted value. At the same time, I want to draw the confusion matrix also between the actual value and the predicted value. So we have used confusion matrix function here. So this is all about the code where we are training and evaluating the random forest value classifier. So you can see here the accuracy of my model is 0.97, and as we have printed the classification report. So classification report will look like this. It will show the precision, recall, FN score, and support. Okay, so it's showing me precision recall on both the classes, on class 0 as well as on the class 1. Fine. So it's giving me all the results and I'm getting the accuracy, okay, which is my 0.997 is my accuracy. Same time I have drawn the confusion matrix, so it's giving the confusion matrix which is 59.4. So it means true positive value is 59 and true negative value is 107. So model is predicting 59 values as a true positive, means positive, predicting as a positive, and 107 values is predicting negative as negative, and these two are nothing but the error, which are wrong prediction. This 4 and 1 is wrong prediction. So this is false positive, which is 4, which is wrong prediction, and this is false negative, which is again the wrong prediction, and 1 is predicting as wrong. So this is about the random classifier. Same way as we are comparing random forest classifier, which is an ensemble learning classifier, with the SVM classifier. So I'm training again SVM classifier here. So we are training the classifier. So we are again calling an SVM classifier here and fitting my model on training data. So I've used data plus their label. And then same thing what we have done in random forest, what we are doing, we are predicting the label, that how well my model has learned during the training. Now I want to check during the testing phase. So I'm giving the test data without label. And now I want to know the performance of my model. So I'm using this particular line of code. I'm checking the accuracy score on test data and the predicted data, and predicted result is stored in SVM underscore prediction variable. Okay. Now the same way I want to print the accuracy. So I just printed the accuracy value. I want to print the classification report. So I'm predicting the classification report between the test data and the predicted data. Same way I want to print the confusion matrix, how I have done in the random forest, because I want to do the comparative analysis. So I have done the same thing what I have done in random forest. Now you see the results when we are executing this, we are getting the result. My accuracy is here 0.93. So if we'll compare with the random forest, the accuracy was 0.97. You can see here there are approximately difference of 4%, which is a very major difference we can say in terms of in the field of medical. Okay, so the difference is a lot. When we are using ensemble learning, I'm getting better result compared to the using SVM classifier. And you can compare the result of precision, recall, and FN score. For precision, we are getting here 1. Okay, here the precision value is 0.98. In the case of 0 class 0, In the class 1, we are getting precision value 0.91, and here we are getting precision value 0.96. Okay, and recall is 0.83 and 1. Here recall is 0.94 and 99. So whenever we are talking about medical data, or whenever we are applying any machine learning or deep learning algorithm on healthcare sector or medical field, always recall will play an important role, as I told you earlier also. So we have to concentrate on recall rather than only concentrate on accuracy. So you can see here random forest is giving a better recall value compared to the SVM classifier. So we can say that ensemble learning is better compared to the SVM classifier because we have compared the performance matrices of both the classifier. Clear? Now, now we are trying to draw the, we want to plot the confusion matrix also. If you want to plot the confusion matrix, you can plot the confusion matrix for both, for your random forest as well as for your SVM classifier. So we are plotting the confusion matrix for both. So when we are plotting the confusion matrix, it looks like this. So this is the confusion matrix for random forest, the same what we got here. So this we got in the form of array. Here we are plotting in the form of graph. So same way, I'm plotting random forest confusion matrix and I'm plotting the confusion matrix of SVM. So I can get a better visualization that how my model performs. So there are total 52 positive prediction where a model is saying that malignant as malignant, and the same way there are 108 times model is saying benign as benign. Okay, so this is a correct prediction where class 0 is predicted as class 0 and class 1 is predicted as class 1, but these are the wrong prediction. These are the wrong prediction. Actual value was malignant and model is predicting it as benign. So that was the wrong prediction here by the model. So which, where we have to do the what we can say, where is a need of improvement. Okay, so here we have a need of improvement. Here we are getting the correct prediction, which is 0. So this is all about your comparative analysis between the ensemble learning models and the normal classifier, where we have used the SM classifier. Now, in the same way, you can compare with the other model also, like you can use k nearest neighbor, you can use decision tree, and you can compare the results with other model also. So this is all about your lab program. Thank you.